Good morning, dear students. Students, we are doing chapter probability, and in today's session we will discuss about those events which occurs simultaneously and dependent to each other. So students, first we have result of theorem 1. If A and B are two events associated with a random experiment, then probability of A intersection B is equals to probability of A into probability of B over A. Students, we use this concept only when the events are dependent. Okay, when question becomes a without replacement, in that case we use this type of results. Okay students, so let's start by solving the problems regarding to the same. Here we have example number 1. A bag contains 10 white and 15 black balls. Two balls are drawn in succession without replacement. Now students, we have to choose two balls in succession one by one but without replacement. And in without replacement, the events are dependent. So what is the probability that first is white and second is black? Okay, here we have to choose first white ball and second one will be black. So let's start. A is the event getting a white ball in first row, and let B be the getting a black ball in the second row. So required probability is probability of getting a white ball in the first and black ball in the second row. So probability of A intersection B. Here events are dependent because we are doing selection in succession without replacement. So in case of without replacement, we use the formula of probability A into probability B over A. So in this way, if we draw first white ball, in this way we have total 10 white balls and total 25 balls in the sample space. So here 10C1 divided by 25C1 and 10C1 is equals to 10, 25C1 is equals to 25. By solving this we get 2 over 5. Now probability of B over A, because students we have selected the white ball but we haven't replaced the white ball. Okay, because we haven't replaced the white ball, that's why the second event B totally dependent on A. So we write here B over A, and B over A means occurrence, probability of occurrence of B when A has already occurred. Okay, here A has already occurred, so we will write probability of B over A. So that's why we have total 15 black balls, so we write here 15C1, but now we left with total 24 balls because total 25 balls are in sample space and we have already drawn one ball of white color which we haven't replaced. In this way we left with 24. So here the probability is 15C1 over 24C1. By calculating this we get 5 over 8. Now by using the values in the formula of probability A intersection B, we get 2 over 5 into 5 over 8, that is 1 over 4. Now students, here we have question number 2. Find the probability of drawing a diamond card in each of the two consecutive draws from a well shuffled pack of cards. Now students, we have to draw the probability, we have to find the probability of drawing a diamond card. We know that diamond is a suit. Okay, we have total 4 suits in the set of 52 cards, and diamond is one suit, one of the suit in which two consecutive draws. Consecutive means we are drawing the cards in continuation. Okay, from a well shuffled pack of cards, if the cards drawn is not replaced after the first draw, if we draw the first card and we haven't and we will not replace that card, okay, that means in two succession the second succession draw is totally dependent on the first draw. So that's why we use here the probability A intersection B is equals to probability A, probability B over A. So students, let's start. First, let A be the event of drawing a diamond card in the first row, B be the event of drawing a diamond card in the second row. Then probability of A is equals to 13C1 over 52C1. That is, by calculating this we get 1 over 4. Now probability B over A is probability of drawing a diamond card in second row when a diamond card has already been drawn in the first row. So its value will be 12C1 because we have already drawn a diamond card. Diamond cards are total 13. So if we have already drawn one card from 13, then we left with 12. Now students, we have to choose one card from 12 cards. That's why we write here 12C1. And total cards now we have 51. Okay, because we haven't replaced the card that we have already selected from diamonds. So now using these values 1 over 4 and 4 over 17 in this formula, we get the answer 1 over 17. So this is the conditional probability. Next we have question number 3. A bag contains 5 white, 7 red, 8 black balls. If 4 balls are drawn one by one without replacement, find the probability of getting all white balls. Now students, in this way we have to find all white balls. Total we have 5 white balls, and so we have to choose one by one 4 balls. So students, suppose we draw a white ball in the first row and we haven't replaced that ball, then in this way we left with 4 white ball. So in next session we will draw next white ball, then we left with 3 balls. In the continuation with the same process, we will draw the 4 balls without replacement. Now here we have 4 events. A, B, C, D denote the events of getting white ball in first, second, third and fourth drawn respectively. Then required probability is equals to probability A intersection B intersection C intersection D. Now students, probability A is completely independent because this is the first row. Now probability B, if we draw the ball second row, then it totally depends on the first event that already happened, and probability of C depends on totally on events A and B. Now similarly, probability of D depends on the happening events. An event happened are A, B and C. Now students, by calculating the values, probability of A is 5 over 20 because we have total 5 white balls and total 20 balls in the sample space. Now probability B over A is, because we have drawn the first white ball, so we have 5 choices at that time, but now we left with 4 white balls because we haven't replaced that ball. So we left with 4 over 19. In the same way, if we draw again the white ball, then we get 3 over 18, that is 1 over 6. In the same way, if we draw again the white ball, then we left with 2 white balls, then we have only 2 choices, then 2 over 17. Now using all the values in the formula, we get, on solving this, 1 over 969. Now students, we have next question, question number 4. A bag contains total 19 tickets numbered from 1 to 19. Each ticket numbered from 1 to 19. A ticket is drawn, then another ticket is drawn without replacement. Find the probability that both the tickets will show even numbers. Students, in this question we have total 19 numbers, okay, tickets that are numbered from 1 to 19. A ticket is drawn, then another ticket is drawn without replacement. So these are the cases of without replacement. That means we are using here this formula, this required result, okay. So find the probability that both the tickets will show even numbers. Let A be the event drawing an even number ticket in the first row and B be the event drawing an even number on the second row. Then required probability will be this formula. So here we have total even numbers are 2, 4, 6, 8, 10, 12, 14, 16 up to 18. So these are total 9 and we have total 19 in sample space, then its probability will be 9 over 19. And same probability B over A is 8 over 18 because we have already selected a number and now we can't repeat this and we are doing this without replacement. So that's why we have total 8 cards left. So if we select again even number from this card, then its probability will be 8 over 18 and we write it as probability B over A because A event has already occurred. Okay, so required probability will be probability A intersection B is equals to probability probability B over A. By using the above calculating values, we get the answer 4 over 19. Now students, we have question number 5. An urn contains 5 white, 8 black balls. Two successive drawings of 3 balls at a time are made such that balls are not replaced before the second draw. Find the probability that the first draw gives 3 white balls and the second draw gives 3 black balls. So students, let's start. This is a similar question. Here we have A event drawing 3 white balls in the first draw and drawing 3 black balls in the second row. That means we are picking 3 white balls together in a draw. Okay, so required probability will be probability A intersection B is equals to probability A probability B over A, because this is mentioned in the question that the balls are not replaced. So that's why this is the case of dependent events. Now probability of A is, we are selecting 3 white balls and we have total 5 white balls, so that's why we will write here 5C3 over 13C3, because there are 13 total balls in the sample space. By using the combination formula, 5C3 is equals to 5 factorial over 3 factorial into 2 factorial. So in this way we get 5 over 143. Now, after drawing the 3 white balls in the first row, 10 balls are left in the back. So, we are drawing 3 black balls in this succession. So, probability B over A is equals to 8C3. We left with total 10 now, 10C3. By calculating using the same combination formula, we get 7 over 15. Now, substituting these values in the required probability result, probability A intersection B is equals to probability A, probability B over A. Now, putting the values, we get the answer 429. Okay, 7 over 429. So students, hopefully all of you get understand and do more and more practice of the same types of questions. So if you like my video, then please like, share and subscribe. Thank you for watching the complete video.